Hello students, in this class we are going to see something more about uh, bitwise operators. And to understand bitwise operator, few things has been already discussed in our earlier class, and in this class we'll see something more. So to understand bitwise operator, let me simulate the RAM through Excel. Now I'm making RAM like structure in Excel so that you could properly understand uh, whatever is happening. Let us number this cell number. Although there are a lot of cells in a RAM, if we have 1 GB of RAM, then we know more than 1 Arab 7 crore such memory cells are there. And each memory cell, this is cell number 1, this is cell number 2, this is cell number 3, and each memory cell is of 1 byte, yani 8 bits. And whatever we store, that gets stored in 1 byte. And let us try to understand this in a better way. So just suppose that if there is any number, let us make a column for decimal number, and we'll be reserving ourselves with 1 byte only. We'll deal with 1 byte only, just to keep the things simple. So there will be no issue. Suppose decimal number is 4. It's binary. Let us use a function that finds out the binary of the number. So the function is dec to bin. Dec to bin, that's 4. L2 contains 4. So this is the binary equivalent of, let me little enlarge it so that you could properly see. Now let me apply this formula till this. Now any number that will write like 65, its binary equivalent will be there. Now let us find the length of, or the number of bits there. 3. Means if we'll convert 65, this binary equivalent is this, and it contains 7 bits. Okay, here y1 is there because 0 is there, that's why. And as and when we'll just say 112, if I'll put, then it also contains 7 bit. So this is how things go. Let us put any other number like 213 or 12. So this is the binary equivalent of that, and this contains 8 binary digits. So now we have made something which will help us to understand how the binary or this operator works. Beside this, you also must see the truth table. Truth table means A, B, okay, and which is represented by this, or which is represented by this. Look, suppose A is 1 and B is 1. What is A and B? If A is also 1, B is also 1, we'll have 1, or also will have 1. If A is 0 and B is 1, and will produce 0, and or will produce 1. If it is 1, it is 0, and will produce 0, or will produce 1. And if it is 0 and if it is 0, then it will produce 0, and then it will produce also 0. So this is the truth table again, which we have already seen in our last class. So this is not tough. This is very easy. And in our last class, we also saw the AND gates and OR gate. This gate is the same thing. A gate has two inputs. It may have more inputs, but just in order to understand the concept, let us assume that a gate contains two input. And just to again revise the things, or just refresh the thing in your mind, let me show you image of logic gates. So look at them. These are the logic gates: AND gate, OR gate, NOR gate, NAND gate, XOR, XNOR, buffer, and a NOT. So out of these, we have to mainly understand AND gate, OR gate, and a NOT gate. Okay. Rest are also very simple, but at your level, if you are understanding only this much, then also it's enough. It's good. NOT means not A, which is represented by this. Whatever the value of A, NOT will be its opposite. Its complementary number. Like if A is 1, then NOT will be 0. If A is 0, then NOT will be 1. The same way, if A is 1, then it's 0, then A is 0, then it is 1. Yeah, this is the output of NOT. So AND, OR, and NOT, these are mainly used. And in the Bitwise operator also, we'll just see them. Now let me tell you the number 3, whose binary is 100, how it is actually stored in RAM. So look, it contains 3 bit. So this first bit will here, then here, and then here. 1, 2, 3, 4, 5, 6, 7, 8. 8 bits over. Now these bits are filled up with zeros, all zeros. So this makes a number 3, or the number 3 is represented inside a RAM like this. A 0 is represented by low volt, whereas 1 is represented by high volt in RAM. How this number 65 is going to be represented? So 1, 0, 0, 0, 0, 1. And this first number is 0. Okay? So this is how the things will go on. But if we are using unsigned, which we just now discussed, then for 212, this is okay. 8 bit is needed, this is okay. But in Java, the number are signed. Signed means the 1 bit is reserved for, this first bit is reserved for representing the sign. This kind of thing is there. So only 7 bits are there for representing a number in byte data type. If we are using sort data type, then it has 2 bytes. If we have int as the data type, if we are making int variable like abc, then it takes 4 byte. This has been already discussed. So let us keep the thing simple and let us reserve ourselves up to this number. Look, if all the 7s are there, then this is the number. So whatever number we'll be using after this or now, they all will be smaller than 127, so that things could go good in your mind. So 56 may be a good number. Let us now represent how the 56 is going to be represented here. So how many bits are there? 6 bits. 1, 1, 1, 0, 0, 0. This is 56. What about these 2 bits? These 2 bits will be 0 and 0. So this is how this 56 is stored in a RAM, a byte of a RAM. Now, what happens with the bitwise operator? Now here comes that. Look at this. So let us also make a simple program to show the bitwise operators. First of all, let me make a very simple program, and I'll be making a very simple program, bitop, to show bitwise operator. And I'm not going to make object oriented. I'm going to make a simple procedural program. Public study environment. I'm writing everything from the beginning so that you could properly understand what I'm doing. So since we have to just learn bitwise operators, so let us not int. We had decided that we will reserve ourselves with byte data type. So let us use byte. Byte a equals, let us take 3, and take another byte variable b equals, let's take 4. We'll see, no need to do these things. Just for the sake of living good, I have given space. Now what? See here. Although the programmer has used int variable, but let us not use int, because if you'll take int, then what? I'll have to take every time 4 bytes to represent a number. And that may be a little complicated to make myself very clear to you. So let us be reserved to byte data type. Although for int also, it works the same way. So see here. Byte c equals a or b. Okay. Now what? System.out.println value of c. Let's see. Now let us close this. I said we'll make simple program. Save it. Let us save it in class 9 with the proper name, bitop.java. Let's go for execution process, where we have to go to E drive cd java class 9 dir. All of programs are there, but our program is bitop, just now saved. Java C, bitop.java. It's compiling. There is an issue. What's the issue? Lossy conversion. Everything is in byte now. Now let me check whether it is working or not. No. From int to chalo. It means that things will work with int. So no issue if the program is not allowing you with byte, because lossy means the data may lost. That's why. So no issue at all. We'll understand this with this also. No issue at all. Okay. So although this will take minimum int as the data type to work with the bitwise, but still, just for the sake of understanding, will be reserved to byte. When we'll just I'll explain the things in Excel, then will be reserved to byte. See the output 7. Now the result is 7. Let us see how. Now here is the main point that you may need to understand. So let us see. The value of A is 3. We can see both the things. Okay. A, variable A. What is its value? 3. 3 The binary of 3 is 0, 0. Fine. What is the value of B? Value of B is 4. This is. Now, let us store them in where? In RAM. 3 will be stored something like this. This all the backend will be filled up with 0. B, whose value is 4, whose binary is 1, 0, 0, will be stored in RAM like this way. What these one cell is representing? One cell is representing one bit. Either 1 or 0 will be stored there. Now, which operator we have used? We have used OR operator, OR. Now, what about OR? Look at this. OR, how it generates 1? A and B are input. Here, 1 is A and here is 0. What will be the output? This is the result of OR. OR. Yeah, this is A and B. This bit of A and this bit of B. If OR operator is applied to them, what will the result of 1? If this is 1, this is 0, this also 1. If this is 1, this is 0, then also 1. Now, since these two all are zeros, so this all will be filled up with 0. Okay. Now let us try to find this is a number. Let us now find use function or bin to deck, which this 111. This is binary. Now here I have applied formula to find out the binary of a decimal. This is binary. Binary is 111. What is its decimal? 7. So when we applied OR operator, the value of C, this is C, okay? C contains OR of A and B, which we are also watching is 7 here. C, output is also 7. Because of this, the value of C has become 7. Now you might understand how this is working. Let us now see the operation int D equals A and B. And before we see the output, let us first find out the output. Okay. A and B. Assume this as the variable D and assume the operator AND here. A and B, these are A and B. First input is 1, second input is 0. What will be the output? Is 0. Here also 1 is 0 and 1 is output will be 0. Here also 1 and 0, output will be 0. Here all will be zeros. So which number it is making? It is making 0. Means the value of A and B, the value of A or B is getting 7, but the value of A and B, according to our calculation, whatever we know, according to if we do it according to the truth table and all, we are getting 0. Let us see what this program is generating. If you are using the bitwise AND operator, then what is happening? Save it. Again, compile it, and again see this. Look, 0 is coming. Now let us find the NOT of NOT, the bitwise operator NOT. How we can find? The same way, of course. Int E equals A not B. And the same way, copy and paste this for E as well. So first, let us try. Let us color this a light way so that we could understand that yeah, these are the cells which we have to add as the which we have to take as input. Not, but actually not is not a what binary operator. I mean, two operands are not needed. Look at this program. Look at this. This is how we can use it. And a. So let us make a modification here. Not b. Let it be not b. Not b. Huh? So not b is in e. This is a variable. These are the variables. Okay. Not of b. B is this 0, not 1. This is again 0. This is will what 1. This is 1. So it will be 0. And all the zeros will become all the ones. Okay. So here we may have some problem because look, 1 1 1 1 0 1 1. 1 2 3 4 5. I have written 4 ones. Huh? Let us see what it displays. Huh? -5. So why it is representing -5? Look, children, what has happened that this first bit is what 1, and it is using the complement. Complement